Planet 9. Is it real? Well, we still don't know, but there has been a really interesting paper published very recently in August of 2016 that actually gives us a very interesting evidence for the existence of Planet 9 that we have never considered. In today's video, we're going to discuss it, and I'm going to explain to you what's going on. Now, if you still haven't subscribed, don't forget to click that subscribe button because there's so many more videos coming in the future. Welcome to What the Math. So we're going to be using Universe Sandbox 2, and I'm going to actually show you a very realistic representation, or I guess a little bit of evidence for why we now think Planet 9 is even more likely to exist. This is actually coming from, I believe it's actually one person paper, or one person that actually discovered this evidence, and this person's name is Dong Lai, and it's a researcher at Cornell University in the Department of Astronomy that actually published very short, very sweet, very beautiful paper filled with math that I'm not going to discuss in this video because it's actually really complex and it would require quite a long analysis actually, but the paper is beautiful. And what it says is this. I'm going to actually go into different simulation here. It says something really simple. It basically looks at all of the planets in our system. It looks at Mercury, it looks at Venus, and it looks at a lot of the outer ice giants, especially Uranus and Neptune. And it only really considers one simple fact. It considers something known as inclination right here. What does inclination refer to? Well, the best way to explain it is to visualize it. Inclination is this. It basically shows us the position, or I guess not position, but the angle that the orbit forms with all other orbits, with the so-called plane of orbital alignment, that is, compared to the other planets. Now, so for if I actually go back here, for most planets, it's not very large. For Mercury, it's actually pretty big. It's about 7 degrees. For Venus, it's about 3.4 degrees. Earth has an inclination of very small inclination of 0.002. Mars has 1.8 degrees. We're not going to look at Vesta and Ceres because they're not planets. Jupiter, even Jupiter has a bit of inclination of 1.3 degrees. Saturn with 2.5. Uranus with 0.7. and Neptune with 1.7 or almost 1.8 degrees. So every single planet in our solar system is a little bit inclined. None of them are perfectly aligned with the plane of orbit. In other words, they're all just a little bit misaligned, and they're all a little bit misaligned into one direction, the direction of this, up. Now, so that's an interesting thing. It's an interesting observation, something that nobody has really considered, or at least nobody has really analyzed in detail. And these planets are obviously very massive. Like Jupiter is super massive. So for something to dislodge it by 1.3 degrees, something really interesting must be happening. Now, here's what this person did. This person by the name of Dong Lai decided to analyze or come up with a very interesting formula using trigonometry and using all kinds of super complex, but I guess relatively simple in astronomical terms calculations. And this person discovered something. He discovered, and I hope it's a he, or possibly she, but anyway, this person discovered the following. He or she discovered that in order for all of these planets to have this kind of inclination, there must be something going on in the outer solar system. And then this researcher made a small assumption. He or she made an assumption that Planet 9 is orbiting in a very specific sort of way with an orbital radius, or so-called semi-major axis, of about 340 to about 480 astronomical units. Here it's, I believe, a little bit more, it's about 500, with a relatively highly inclined plane, and obviously with somewhat high eccentricity of anywhere between 0.2 to about 0.6. The researcher actually analyzed various possibilities, graphed them, and displayed them in the paper, showing that if you actually have something like Planet 9 orbiting here, and if you have our planets orbiting in a regular sort of pattern, without any inclination, without any eccentricity at first, with time, after billions of years, they actually do acquire the inclination that is present here. Maybe not exactly that inclination, but almost exactly what you see here. And interestingly, I actually decided to try this myself using the Universe Sandbox, but it obviously would require billions of years. So what did I do? Well, of course, I set up a little miniature system, kind of something similar to what I'm about to show you. I basically put, and you of course are more than welcome to try this yourself if you have the game. I put the sun in the middle, then I moved out to the outer solar system, and I believe it was Jupiter actually. I put Jupiter at a distance of about 5 astronomical units, and then I put Neptune at a distance of about I think it was about 25 or 20 astronomical units. Made sure that their actual eccentricity and inclination were 0. I made sure that this was 0, and then what I did was I added another relatively large object, and I think here I actually just use Uranus because it is a little bit more massive than hypothetical Planet 9, but I just didn't want to create a new system using completely brand new Planet 9, so I just put Uranus. I put Uranus at a distance of about 340 or 350 astronomical units, but I also gave it eccentricity of about 0.2 or 0.3 and inclination of about 35 degrees. So I did that. And then I let it spin, and I left, or actually I didn't leave, I went to bed. This was an overnight project. I went to bed, and then I woke up. Now, interestingly, you can probably guess that something happened. And I'm going to show you what did. So we're going to go into my simulation that's sort of like already 1.5 million years old, because here you can see this is only 1 year old. And so 1.51 million years later, with the Uranus orbiting in a kind of a Planet 9-like fashion, and Neptune and Jupiter right there, this is what I've detected. I've detected both eccentricity and a little bit of inclination. 0.007 and also 0.007. I kind of realized that if I keep running the simulation for many more millions and billions of years, this is very likely going to change, and very likely is going to become possibly higher. And at some point, they are going to achieve a kind of a resonance, or possibly a kind of a balance, where this inclination will no longer change as much for either one of these objects. Now, this was really, really cool. I did not expect this to happen. I actually thought the paper, might be not particularly accurate, or maybe this was a far-fetched sort of hypothesis. But you know what? This totally makes sense. So this is a relatively massive object, but it is very far away. So it's not going to influence these planets very, very quickly. It's going to influence them over millions and billions of years. And it totally did. And these objects obviously have a lot more effect on each other, but because they have a relatively similar plane, they are not really going to influence inclination. So there's only one explanation to why inclination is different, and this is right here. This Uranus that really should be called Planet 9. Now, I may actually run this a few more nights, or I think you should definitely try this yourself so you can actually see the effects by yourself. But this is a brilliant explanation. I'm actually kind of surprised we haven't heard from anyone about this yet, because this would really be the obvious thing to look for. But this researcher from Cornell University by the name of Dong Lai may have actually hit a jackpot in the one of the more obvious explanations, or I guess evidences for the existence of Planet 9 somewhere out there, 300 to maybe 500 astronomical units away, orbiting in a very highly inclined and very highly eccentric orbit around our sun. This is possibly why the inclination is present in every single planet in our solar system. And this is actually, I remember now, this is one of the questions I asked my teacher a long time ago when I was really little and I studied planets and space sciences. And I actually asked, so, why is it that, some things are inclined? And I believe until now the answer was that, nothing is perfect in the solar system. When the planets are forming, something may have dislodged them. But this never really satisfied me, because there is absolutely no reason for such an inclination to exist anywhere with some of the bigger planets, like, for example, Saturn and Jupiter, because they're massive enough to not be dislodged by collisions. But something did dislodge them, something did create this inclination of 1.3 and 2.5 degrees, and that something is the mysterious object known as Planet 9, orbiting somewhere out there with a very funny very interesting orbit that you can see right here. And anyway, so that's all I wanted to talk about in this video. I thought it was a pretty interesting discovery. I thought it was a pretty interesting paper. You can definitely check out the paper itself in the description below. It might be difficult to read, but you may just go through the introduction and then the conclusion just to get a gist of it. But yeah, so maybe, just maybe, we have more evidence and we'll be able to find Planet 9 a lot easier now. Thank you so much for watching. I'll see you guys in the next video. Share this video if you've actually enjoyed watching it. Subscribe if you still haven't. Like this video if you actually learned something. And don't forget to actually be a subscriber because there's a lot more videos coming in the future. If you enjoy this channel, don't forget that you can also support us on Patreon and help me purchase better camera sometime this year, hopefully. I'll see you guys in the next video. Game you later. And as always, bye-bye. And Planet 9, we're going to find you. Hopefully this year. But if not, maybe next year. Hopefully, basically, before I die because I want to see you. Okay? Cool. Stay wonderful, wonderful people. And watch the space. And also look at these wobbly orbits. Why are they wobbly? Well, we'll possibly talk about this in the future.